Good afternoon and welcome everybody to today's webinar, which is driven by data, rethinking infrastructure. My name is Jessie Paul and I'm the CEO of Paul Writer. I am your host for today. And it's my pleasure to introduce our speaker, who's a very strong expert in the space from IBM, Mohammed Pasha, who is in the IBM Systems Tech Sales division. And thanks for joining on time. As you know, we do these sessions with IBM pretty frequently, and the ground rules remain the same. We would really appreciate it if you could stay on mute and switch off your video so as not to disturb the other participants. And we will be sharing the recording with everyone who's here today, so you don't actually have to take notes if you don't want to. And you can post any questions you have in the chat window, and the speaker will take a look at that and respond as soon as there is a break. Or we will have a set of questions being asked at the end of the session, so you could reserve your thoughts till then. But as you have a question coming up, feel free to post it in the chat window so that we can post it to the speaker for a response. And so with that, I'm really happy to hand over the platform to Mohammed Pasha.
Thanks a lot, Jessie. Good afternoon, everyone. My name is Mohammed Pasha. I'm a storage architect, part of IBM's pre-sales team, and I take care of large enterprise accounts for storage and software-defined storage in South India. Okay. So as Jessie has set the agenda, so let's start with the presentation. I'll be sharing my screen with you. Let's keep this session interactive at any point of time. If you have any questions for me, you can just post it in the chat window. I'll be more than happy to answer the queries. Okay. Alternatively, we can schedule last 15 minutes for answering the queries if you have. All right. Are we good to go?
Sure, go ahead.
Yep, thank you. All right. So are you able to see my presentation? Are you able to see the deck?
Yes, I can see your screen.
All right. So in next half an hour, also we'll be speaking only about data, and data, right? How's, like, where is data, how is data, and how important it is to think about data. Okay. So the agenda for this discussion would be give me a minute. Okay, so let's discuss something about data and multi-cloud patterns. Why flash storage? How flash will help in accelerating the workloads in multi-cloud environments. Let's spend some more time in understanding what is NVMe and how it is relevant to IBM's flash portfolio and the flash portfolio in general. Okay, and let's have a look at IBM's offering when it comes to flash. Okay, and then, as I said, we'll set aside some time for taking the questions. To start with, as I said, it's data everywhere, right? Why are we so much concerned about data, right? Like the Economist says in 2007, like oil is no longer the most valuable resource in the world, but it is the data. How efficiently you make use of your data is what matters in this era, right? At the same time, we are thinking about cloud architecture. 2-3 years before, we were thinking about hybrid cloud, private cloud. Now, all the decisions in IT are made thinking and keeping multi-cloud environment in mind, so that we can extend data across infrastructures. Okay, we have choice control and consistency on the data that we put on the cloud. Okay, and the movement of data across the cloud environments is easy and agile. Put exactly at the same time, when we speak about multi-cloud environments and data, each and every organization wants to go digital, right? As IDC says, by 2020, 50% of G2000 will see majority of their business depend on the ability to create digitally enhanced products, services, and experience. How do you do that? It is the way you mine your data, right? It is the way how you make use of your data, right? So let me go to the next slide. Why storage? We speak about data, how to make use of the data, and why storage? How will storage help you in reaching the goals that we set to become a digital organization, right? As I said, if we are making use of our data efficiently, okay, that is better management of the data will definitely lead to better IT and business outcomes. Okay, just to reiterate, if you make better use of your data, you can see more than 7x high success rate, like high levels of success. Okay, that's by making use of your data to predict the trends, the business trends, and forming the goals accordingly. You can see 10x chances to outperform your competitors. Okay, and with all these things, you can have up about 14x growth in your revenues. Uh, okay, how do you invoke insights from the data that you have, right? So you'll be having data in your environment. There will be data uh, outside your environment, that is outside your firewall, like uh, your social media data, the weather data, right? And the data that is sitting almost untapped, data like digital intelligence. So all these things put together will determine your digital intelligence. Okay, let's talk about dynamics of storage. Right now, we see that big data is transforming the entire world, right? Big data is one of the most talked about topics in the industry right now, whether it is research, government, different verticals, right? It is the most talked about topic in the industry. It is becoming an integral part of everyone's IT ecosystem across all the verticals, including agriculture, education, energy, entertainment, healthcare, and so on. At the same time, we see there is growth, how the data is growing, right? So I would say, uh, like data, the volumes of data, it is growing. Look at the velocity of the data as it is growing, right? When I speak about volumes, data continues to double every 9 months. And look at the velocity of how fast our data is moving, coming into your environment and moving out. So this is not restricted only to volumes and veracity, right? So data, you need to look at the value that is there in the data and the veracity of data and the variety of data, right? Data is not coming in structured tables, right? It's all unstructured data, images, video files, sensor data, video data, logs, and so on, right? And the value, okay, data becomes a resource on which you can mine and build a value for your competitive advantage, right? At the same time, it has a veracity of data, the accuracy and integrity, right, based on which you can take decisions to take your IT to the next level. It's the growth in all about that is creating demand for extremely efficient, scalable, high performance storage solutions. So this is not restricted only to a particular environment. It can be multi-cloud environments. It can be a combination of, it can be a hybrid cloud environment, right? It can be a on-prem environment. Let's understand something about data services. What exactly is data services? To help you better understand what data services are and what they provide, let me first start with by sharing with you IDC's perspective. IDC describes data service for hybrid cloud as location infrastructure independent software that understands and okay, performs various protection, security, integration, and optimization functions on the data for purpose of business controls or SLAs. Basically, data services for hybrid cloud moves the data, optimizes it, protects it, secures, and orchestrates through different policies, right? And these storage data services in multi-cloud environments offer the ability to prepare and provide data to the infrastructure such that multiple lines of businesses can access the data simply, okay, without any complications, securely, at the same time taking the compliance into consideration. Okay, so if you look at the technical attributes of a multi-cloud environment and data services, uh, it should have multi-cloud capabilities, automation and orchestration, self-service, data masking, and most importantly, the speed with which you can access the data, that is fast data access, right? So to provide these attributes, my infrastructure has to be ready, right? The infrastructure should have high performance, a reliable infrastructure where security would not be a concern, and the integration with the outside world using APIs. So putting everything together, data services in a multi-cloud environment will enable businesses to develop solutions using the data. Do we have any questions till now?
No, I don't see any.
All right. Okay. Let's look at the current architecture, right? We have different cloud solutions, like we have Azure, we have Google Cloud, we have uh, on-prem solutions, like we'll be having Oracle running on Power Systems, SQL running on x86 servers. I have a question coming up. Give me a minute. Okay, in this slide, we will look at some of the multi-cloud patterns. Okay, in the previous slide, we had a look at the on-prem solutions and different segregated cloud solutions, right? So when we move to multi-cloud environments, we want a interoperability between all these clouds. So I may have my DC running out of Azure. I may uh, need a DR sitting on IBM Cloud, NDR sitting on AWS, right? How do I have to do that? Like, look at the solutions what we will be having in our environments, right? Like VMware, Oracle, SAP HANA, SQL, right? And next-gen applications like MongoDB, Spark, Cassandra, Hadoop, okay, and containers like Kubernetes, OpenStack, Docker, right? If I have to move these workloads to a multi-cloud kind of environment, what do I want? What do I need? I need to modernize these traditional workloads, okay, for which the private clouds should be agile, flexible, cost effective, right? And they should support the next gen applications for AI and big data, okay, so that I can make use of the open source uh, applications like MongoDB and Hadoop. Okay, it should support integrated Docker and Kubernetes, right? And how does IBM deliver? How does IBM caters to all these requirements in multi-cloud environment? So on your right hand side, you have a portfolio of IBM uh, where we can help you. in achieving and modernizing your traditional workloads when you move to cloud environments. We have IBM Spectrum Virtualize, we have IBM Spectrum Accelerate, Spectrum Archive, Spectrum Data Copy Management, Spectrum Protect Plus, and more importantly, all flash solutions to modernize your traditional workloads, right? And transforming, if you have to work with next-gen applications like Hadoop, MongoDB, and Spark, we have solutions like Spectrum Storage, Spectrum Compute, Spectrum Scale, Spectrum Cloud Object Storage, all flash that can support you in transforming your workloads across multiple cloud vendors or multi-cloud environments, be it for applications like MongoDB, Hortonworks, Hadoop, or be it for high performance computing across multiple cloud architecture, right? And if we were to speak about uh, the applications like containers, we have solutions like Spectrum Virtualize, Spectrum Computing, Storage, Spectrum Access Print, and more importantly, all flash, IBM's all flash solutions combined with IBM's cloud. Am I audible? Like I see there is a fluctuation in the link.
Audible
You
to
see?
me. It's working for me. There is an occasional drop, but that could be because maybe you need to be a little closer to your mic.
Yeah, I'm closer to the mic. I just got a message that my connection is unstable.
We can hear you. It's fine.
All right. So with that, at a high level, this would be the data-driven multi-cloud storage architecture, right? Wherein I could work with multiple cloud vendors, multi-cloud environments. Like I can work with Azure, I can work with IBM Cloud, AWS, IBM Cloud Private. At the same time, I can have my own on-prem cloud, private cloud, right? So you'll be having the flexibility. You will move your workloads to uh, so that they can support next gen applications and integrations. Okay, at the same time, your environment will be agile. Okay, this is about cloud multi-cloud environments. Okay, let's spend some time. Uh, we have like I have a few questions for you. Okay, at this point of time, uh, Manjunath, can we have some questions for the participants over here. You can answer the poll. What are your priorities for storage infrastructure? The previous one. I would request everyone in the session to take out a couple of minutes in answering to this poll. All right, so let's move on. Okay, we spoke about multi-cloud architecture, multi-cloud solutions, the requirements, the technical attributes of multi-cloud environments, right? The most important part over here is, as we saw in one of the previous slides, it is the speed at which you can access your data, right? So I have a chart. The next chart speaks about how speed matters, right? How latency matters. Just consider traditional storage, okay, in comparison to a flash storage. It is it is similar to waiting near a toll plaza, right? So if you were to pay amount and clear a toll booth, the amount of time that you wait at the toll gate, compare that time if you have something like FASTag, wherein you can just swipe your card and cross the toll booth, right? Just apply that analogy over here. If you see this particular illustration, okay, with respect to a normal SAS architecture or a SSD-based architecture, my CPU wait time will be more, and the efficiency, the utilization of CPU will be very less, because most of the time my compute, my server will wait for the IOs coming in from the storage, right? What if I say that I'll decrease that latency, okay, by increasing the performance of the storage? My CPU utilization will go high, okay, and at the same time, the time that CPU spends in waiting for the next IO, it can cater to different applications. So there's a difference. Compare the utilization of the CPU on the left-hand side to the utilization of the CPU on the right-hand side. Okay, the utilization of CPU increases. Okay, with that, I will move to IBM's offering on Flash. Okay, so let's see how Flash has evolved over years. In 2007, Stick said, we have got this unique device that we figure could revolutionize the enterprise storage business. In 2008, IBM demonstrated 1.2 million IOPS at 1 millisecond latency. Just look at the latency. Okay, just compare this latency to the previous chart what I showed. Okay, 1.2 million IOPS at less than 1 millisecond. And in 2018, we announced a new member to our Flash system family, okay, which according to Forbes, they say that this week's announcement from IBM keep IBM storage in the top tier of storage provider. Just to speak about the numbers, we are the number one Flash storage providers in the world. Okay, I'll take you through the quadrant at the end of the slide. Okay, so when we speak about Flash, what comes into mind? So if I were to speak about Flash to someone, the first thing that comes into his mind, or let's say the otherwise, if someone is speaking to me about Flash, the first thing I'll think about Flash is, okay, Flash means SSD. Is it right? Yes, it can be. SSD is a type of Flash. But there is a difference between the SSD Flash and the Flash solutions, what I'm going to speak about. So you cannot, even by looking at it, you cannot make out which one is a SSD drive, right? Because the form factor is same. Just look at the interfaces. Okay, your SSD will have your normal disk, SAS disk will have this SATA interface. Your SSD will have SAS interface. Okay, whereas the Flash solutions, what I'm speaking about, in something called micro latency module, will have interfaces like this. And right now, everyone, since the industry is completely transforming towards NVMe, the NVMe interface would look like this. Okay, so you were to ask me, since I have spoken about SSDs and Flash modules, you might ask me what is the difference between SSD and a Flash module. Here it is. The architecture difference. SSD comes in the form factor of a disk, whereas my micro latency module looks like this. I'll spend more time speaking about our micro latency module. Just have a look at how it looks like. Okay, so moving on, let's continue looking at the evolution of flash storage. In 2007, the capacity on a flash drive was 73 GB. Okay, just look at the evolution from 2010, 2014, 2015. Okay, and in 2015 is when IBM launched micro latency modules on FS900. Okay, in 2016, first 3D MLC drives were manufactured and offered on IBM's storage family of storages. In 2017, the capacity increased. So since 2015, in 2015, as we introduced the micro latency modules, we decreased the latency on the flash system. And in 2017, keeping that intact with microsecond latency, we doubled the capacity, we increased the capacity by bringing in compression within micro latency modules. And in 2019, we launched NVMe compatible storage. That's Flash System 9100, okay, which comes with hardware compression, encryption, everything. So just look at the trend onto your right hand side. Okay, so I'll spend next 10 minutes speaking to you on IBM's FlashCore modules. So before I move into this, do we have any questions? Let me look at the chat window.
There's just one question which is around the TCO and how does this reduce or do anything to that?
Okay. Should we take it right away or shall we take it?
Yeah, I'm just giving you a question that came to me. That's it.
Okay. On the TCO using flash systems, right?
Yeah.
Okay.
I can't hear you now.
Good. Okay. I'm audible now?
Yes, you're audible.
Yeah. Okay. So let's move directly into FlashCore modules. Let's spend some time speaking about FlashCore modules. I'll come back to this slide. Okay. So what exactly is micro latency module? So you saw SSD drives, you saw micro latency module. How are they different, right? So we saw that front and rear of micro latency module and SSD drives, they were different. Okay, there were additional controllers and chips on a micro latency module. Okay, whereas it was not there on a SSD. Right now, SSDs have become more robust in the last couple of years, while they are not as robust as micro latency module. Okay, so if you were to ask me how are they different and which one is better, it depends. It is, if the cost is the gauge, then SSDs are better. If the performance is the gauge, then I would say micro latency modules are better. How? Our micro latency modules are engineered for flash. Okay, so they have hardware accelerated IO, they have advanced flash management, everything on board the flash module. Okay, before moving into the next slide, okay, so SSDs typically sit in a SAS defined architecture, right? So all the vendors who have SSD drives in their offerings, at the back end, it will be a SAS plane to which my SSDs will be connected. So even though the throughput of a SSD is in Gbps, multiple Gbps, hundreds of Gbps, the limitation of a SAS link is 12 Gbps. A SAS link is only 12 Gbps. So even though the SSDs could deliver more throughput, the performance will be limited by the SAS link. Okay, whereas for these micro latency modules, there is no SAS path. Okay, they directly connect to the CPU. How? I have a diagram, I can show it to you. Okay, so on the design aspect, they are 3D TLC flash designs. They are highly parallel. Okay, they have FPGA controllers sitting on every micro latency module. As you can see here, if you can look at uh, if you can look at to the right hand side, you have the controller sitting on the extreme right, 4:1, 4:1. These are the FPGA controllers that sit on the flash modules. Okay, so they have read ahead and cache enabling, thereby they reduce the latency. Okay, they have 4 plain programming to lower the overall power during write operations, right? And more importantly, they are covered by variable stripe write. Okay, what exactly is hardware accelerated IO? The flash system compression, as I said, these FlashCore modules comes with inbuilt compression capabilities, right? So this compression capability is a modified GZIP algorithm, which is taken from IBM's mainframe systems. Okay, as you can see, this technology originated with mainframes, which we have adapted in micro latency modules. Thereby, we can improve the economic performance impact. So when I say no performance impact, you might ask, okay, so if we were to compress or deduplicate our data, definitely there would be an overhead on the controller, storage controller. But in this case, it is not, because compression is performed as the first step for the incoming data. Okay, and decompression is the last step that happens to the outbound data, right? So this minimizes the data of this minimizes the delta that is written onto the flash modules. Okay, and the ECC is implemented on top of this compressed data. So as you can see, compression and decompression are completely transparent above the FlashCore modules. Let's move to the next slide. What exactly is variable stripe write? In a traditional storage, what we do is we add SSDs. Say we might be having an enclosure of 24 or 25 drives. We add, say, 24 drives in an enclosure. We create a RAID group. We form 2 or 3 RAID groups. Give it like one RAID group can be of RAID 5, one can be on RAID 10, right? And then we carve out, we create pools and carve out volumes from them, right? So that RAID is managed by the software that is sitting on my controller. Okay, that is all these operations and the write operations, everything is managed by the controller. It is the software path that is coming into between my data and the controller. Whereas in a FlashCore module, everything is done at the hardware level. Okay, you have 2 different RAIDs on FlashCore modules. One RAID happens at the chip and block levels. Okay, so as you saw in the FlashCore modules, you have multiple chips, right? What IBM does is it implements something called variable stripe write. Okay, wherein we view flash chips as more than one single entity. Okay, when I say that, within a flash chip, we will be having multiple cells. Okay, what we typically do is we over-provision the capacity on FlashCore modules. Okay, so if I form a RAID 5 of say 16 chips, and if one of the chip fails, it automatically FlashCore modules, the FPGA controller sitting on the FlashCore module, it automatically changes the RAID to it marks the failed cell as failure, and automatically it manages the wear and tear, right? So as you can see, the flash chips are more than just an entity. Our FlashCore technology enables us to see a collection of other components also, like cells, blocks, and layers. Okay, and FlashCore modules we support a variable stripe, right? Just like micro latency module, what I'm speaking about. Okay, wherein if one of the cell fails, automatically the micro latency module will reduce the number of cells in a RAID. Okay, and on top of that, you have RAID at the controller level also. So in a controller, if you're having 12 flash micro latency modules, one RAID level is done. This VSR is done at the micro latency level, micro latency module. The second RAID comes into picture at the flash system. So if you have 12 modules in a storage system, one will in a RAID 5, one module will be dedicated for parity, another one will be dedicated for spare. So your RAID protection is done at two-dimensional layer, one at the micro latency module level, and the second one is done at the entire storage subsystem level. All right. And who has this technology in the market? It's only IBM. Okay. So the flash modules and dynamic RAID work together to offload the RAID rebuild. Summing up, the key differentiators of micro latency or FlashCore modules are innovative ACC algorithm that corrects very high bit error rates but does not require additional rates. So by decrease the latency. Okay, health binning and heat segregation, as I said, in case if there is a failure of a particular chip or a particular cell in the FlashCore modules, there is automatic rebuilding that happens, right? And the health binning and heat segregation happens automatically. The FPGAs take care of that, so that the FlashCore modules continuously it monitors the health of each and every cell, each and every chip, right? And it takes care of the placement of data, right? So which are the healthier blocks where I can place the data. Okay, if a particular block, if a particular cell has reached the endurance period, then it will not write data to that particular chip, right? And write amplifications reduced by 45% by grouping like heat levels. Powerful checks on entire data path, including the flash modules inside. VSR reduces what needs to be retired. Hardware compression can reduce write amplifications since very less data is written on the FlashCore module. So the results are large endurance, asymmetrical wear leveling results, which results in higher endurance for workloads which demand high IOPS, right? So that you can see very less failures of FlashCore modules. So we have invested a lot of time into research, and we have developed this FlashCore modules. This just the picture onto your right hand side is of one of the benchmarks what we done with the FlashCore module. Okay, I'll spend some time speaking about NVMe. Okay, since NVMe is catching up and every vendor is having storage which has compatibility with NVMe. What is NVMe? Okay, is it a replacement of the existing FC technology? No, it is not. So you looked at the architecture of FlashCore modules that we spoke a while before, right? So unlike my SSD drives, FlashCore modules will be directly interacting with the CPU of a storage that requires a dedicated path, and NVMe provides just that. Okay, it's an open collection of standards and information to fully expose the benefits of non-volatile memory storages like micro latency modules. Okay, it is designed from ground up to deliver higher bandwidth and low latency storage access for current and future technologies. So we have two things, NVMe and NVMe OF, right? So NVMe over Fabric, it what exactly it does is it is an extension of NVMe that enables tunneling of NVM command set over additional transports beyond PCIe. Okay, like you can make use of FC Fabric to extend the capabilities of NVMe to the hosts. Let's look at how NVMe has evolved from 2011 to 2018. Many changes. Okay, and right now what we have is uh, complete, or we have a solution through which we can directly support NVMe based hosts, NVMe based architecture. All our storage uh, models are NVMe ready. Okay, just looking at how is NVMe different from SCSI. You can see how different it is from SCSI. You can look at the number of command queues that SCSI has, that NVMe has, right? What is the queue depth? So NVMe has a higher queue depth, and the max it can handle more command sets than SCSI, thereby improving the performance of a storage, right? As you can see, you have a host which has different cores, and you can see the IOs between the storage and the host, right? You can see the efficiency, you can see the parallelism and multiple threading of NVMe. So benefits of NVMe, it has direct attached performance with all the flexibility of being on a SAN, right? Right now, what we are doing, NVMe architecture is nothing but we are replacing the traditional SCSI with NVMe over the fabric ready infrastructure. Okay, it has the potential for improving the latency compared to SCSI. You saw the difference between SCSI and NVMe in the previous table, right? NVMe has better latency and IOPS when used with parallel applications. So thereby, you can reduce your cost of licenses for applications or even the databases. How? Less server CPU core time spent on IO means more CPU core times for your applications. More CPU time for application means few per core licenses to buy, right? So uh, this will be if you're using a flash, okay, with NVMe, ideally you will make use of all the cores in your system, right? And if the utilization of cores improves, then you may need less number of cores sitting idly, okay? And your applications and workloads will make use of the cores to the maximum so that you do not have extra cores sitting idly. And the kind of licenses what we have in the market, which depends on number of cores, that count of licenses decreases, okay, thereby decreasing the overall TCO. Uh, Next couple of charts have some results from the demo that we had with SCSI and NVMe. Let's look at the latency, what NVMe has on the SCSI. Look at the IOPS that were delivered by NVMe based storage and SCSI based storage. look at the CPU utilization. Okay, so with that, I'll jump into our portfolio of storages, what we have to offer for data-driven multi-cloud architecture. Okay, so the approach that IBM has been taking is a software-defined approach, and by doing that, we have seen our customers making use of our software-defined portfolio, benefit with it. Okay, and through the benefit of customers, right now I can say that that has made us number one in software defined offerings. Okay, IBM stands number one for software defined storage in the industry. Okay, we have software defined solutions for all kind of workloads. Okay, the workloads which can form foundation for multi-cloud and AI kind of environments. Okay, we have full suite of software defined applications for on-prem solutions, cloud solutions, using which you can increase the flexibility by decreasing the costs, right? And then we have IBM's Flash portfolio, okay, with a combination of SSD and micro latency modules, both, okay, using which you can deliver millions of IOPS within a smaller footprint and with a latency of microseconds. Okay, and then modern data reuse and protection. We have applications that you can use to unlock value of your data like DevOps, test dev, analytics. Okay, so this is the portfolio of storage and software defined storage what we have. Okay, I'll just take you through the portfolio. For backup and archive kind of applications, we have Spectrum Protect, the erstwhile TSM solution. It is a backup software to back up your data. And then we have, for the virtual environments, we have an extension of IBM Spectrum Protect. It is called IBM Spectrum Protect Plus. Okay, for archival kind of workloads and archival kind of requirements, we have IBM Spectrum Archive. Okay, at the infrastructure level, for object-based solutions, we have IBM Cloud Object Storage, which can scale to multiple sites. Okay, so that will provide you the security of data even if one geographical site goes down. Okay, then we have Spectrum Virtualize, okay, through which you can virtualize anything under the sun in IBM's storage Spectrum Virtualize family of storages, right? And then for high performance kind of workloads, we have scale out, IBM Spectrum Scale, okay, it is a complete scale out file storage environments like HPC, AI, right? Then we have scale out block storage, which includes flash system A9000 XIV. Okay, and then we have traditional NAS storage. Okay, and coming to all flash offerings, that is, when I say all flash offerings, I mean using flash system 900, using micro latency modules. We have FS900, we have flash system 9100. So flash system 900 will have micro latency modules that you saw earlier in the comparison with SSDs, whereas flash system FS9100 will have same micro latency modules in the form of a 2.5-inch FCM drive. Okay, and then on the higher end storages, we have DS8K family of storages, which have both hybrid storage as well as all flash storages. We have DS888-4 hybrid storage, we have 888-6 hybrid storage, we have 888-4F, 888-6F, and 8888F all flash high-end DS8K family of storages. Okay, and then we have tape and virtualization, right? So we have again, IBM is a leader in tape industry, right? Be it the tape media, be it the tape libraries, right from an autoloader, we have a library which can scale up to 18 frames, right? So I'll just come back to virtualized multi-vendor storage system. We have a StoreWise family of storages, which has V5000 family of storages. We have StoreWise V7000, which also offers all-flash storages with SSDs, and V7000 next generation storage, which we will be announcing soon, has NVMe drives inbuilt. Okay, along with that, we have flash system V9000 and SVC, SAN volume controller, which is used to virtualize any storage in the industry to have a uniform management. Then, how do you manage all these things? How do you manage different storages? Okay, how do you monitor the IOPS? How do you pull out historical reports? You have something called spectrum control, through which you can monitor the complete storage environment. Then you have IBM Spectrum Connect for containers and VM APIs. If you have to maintain multiple copies of your data, we have Spectrum Copy Data Management software for DevOps kind of environment. Okay, we have Spectrum Access Blueprint for private cloud. We have Spectrum Virtualize for public cloud for DR sites. Okay, and then for cluster virtualization for servers, we have IBM Spectrum LSF for HPC kind of workloads. For analytics, we have IBM Spectrum Symphony. For new generation workloads like Hadoop, MongoDB, containers, we have IBM Spectrum Conductor. So with this, I would like to finish my presentation. And one thing that, okay, I'd like to add one more thing before I conclude. We also have, along with Cisco, we have a hyper-converged infrastructure, wherein you will be having IBM's storages combined with Cisco's compute and Cisco's networking to give a converged infrastructure. It is called Versa Stack solution. So you can have V5000, you can have the complete storage family in combination with Cisco's compute and Cisco's networking. You can have the flash system family in combination with Cisco's compute and Cisco's networking to give a converged infrastructure called Versa Stack. With this, I conclude my part of the presentation. So this is not end of the session. Remaining 10 minutes or 5 minutes, whatever time is left out, let's take some questions from the audience. Okay, I would be more than happy to answer the queries. Also, you have my mail ID. If I'm not able to answer the questions over here, you can directly write to me. I'll be more than happy to answer to the queries that you have. Thank you. Thanks a lot for joining this presentation. Okay, and thanks, Jessie, for setting up the webinar.
Thanks so much. I think it's been a very intense session. So the question which had come earlier was about TCO. There's also one question on latency, as in, when you talked about latency, what are the advantages of, increasing latency to virtually zero almost, if you're already at a decent level of performance?
Okay. All right. So latency, what exactly is latency? Right? It is a response that we get from our backend storage, right? So let's take an example where I have a server, I have a storage, okay, and my compute will be waiting for the response from storage to perform the next operation. So until the response comes in from the storage, okay, if the storage is performing low. So if the storage is having a latency of say 3 microseconds or 5 microseconds, for that much time my CPU has to sit idle. Okay, and if my CPU is sitting idle, I'm wasting so many cores sitting idle without performing any task. And at the same time, if there is any other uh, task or a thread that is assigned to that particular CPUs, like I won't be finding any free CPU, and there will be a lot of buffer time, wait time for the next task to be performed. Okay, in that case, if I bring in a faster performing storage like flash system, which has very less latency in microseconds, right? So the CPU will be used more efficiently. And if my CPU is completing a task within microseconds, then there is no CPU wait time. The overall CPU wait time and CPU idle time gets reduced, right? So if that happens, okay, uh, the number of cores that are required will reduce. Okay, if the number of cores are reduced, then just take an example of Oracle workload, right? With the license, Oracle licensing is done based on the number of cores. Okay, if my latency is reducing, the CPU wait time will reduce. If the CPU wait time reduces, the number of cores required is reduced. If the number of cores required is reduced, then I might procure less number of licenses. So by reducing latency, I'm improving the overall TCO of my uh, data center, both compute as well as storage.
There's also one request that you put up the last poll question, because I think we're almost out of time.
Yes. Can we put up that question, please? So I believe I have answered to both the questions using that, both TCO and latency, because the overall TCO depends on the latency. Okay. This is the last poll question, and I would request everyone to answer this. Would you like us to get in touch with you? I would request everyone in the session to choose one of the answers. I would be more than happy to invest some more time some other day taking you through our flash system portfolio, how exactly it is different from the vendors in the market, the benchmarks that we have set, right?
Great. Maybe you could also just, give your email ID to the participants right now in the chat window if possible. Because we're also
Here is my
out of,
mail ID.
yeah, perfect. Okay, yeah, because we couldn't see that. So with that, I think we're out of time. And like I said, it's been a very intense session, and we will be sharing the recording with all the participants, and you do have Mohammed's email ID here, so you can ping him directly. Thanks again for joining us today, and it's been a pleasure hosting you all. Have a great evening.
Thanks a lot, Jessie.
Thank you.